Hello, in this video we will talk about k-nearest neighbors in Python. K-nearest neighbors is a machine learning algorithm which is called a lazy learner. It is called lazy because it does not create a parameterized model. It just uses the sample size and train the new unobserved labels with these neighbors in this training set. So always look at the training set, not create any parameter model. And the steps for a k-nearest neighbor algorithm can be followed with these steps. So first we choose the number of k and a distance metric. So this is a metric maybe Euclidean, and k, for example, 5 in this figure. So if we want to classify this new data, so we just select 5 nearest neighbor based on this distance metric and find the k nearest neighbors of the data record that we want to classify. So here is 5. And we assign the class label with a majority vote. So because here the majority is with this shape, so we classify this new data also with this class. So this is the predicted label is this triangle shape. So next we will show how to implement k-nearest neighbor in Python. So if you want to read the code files, you can download this file from this link. And we have also a website for Python and R training on weekend with video in Zoom. This is a paid course. If you are interested in, the course takes 2 days. As a Python and R, 2 days, about 8 hours on Saturday and Sunday. You can check the time if you are interested in. So next we go to we go to Python. We just set the working directory and import all the packages. Successful. We just skip this several part, does not want this. So we load the data for the ELIS dataset and select the third and fourth features of this dataset as the training data. Then we also get the labels for the Y, for the target. And we will create a training data and a test data from original training data with the 30% for the test size and stratify Y. So we keep the distribution for 3 classes. And we will show how it is going. So now the original training data 50, 50, 50 for 3 class labels, and now the new training in the Y, the new training data has 35 for each class and the test data for 15. So it should keep the distribution for each class now. Then we create the standardized, the normalized data for training, because the distance measure is based on such each variable, each feature have the same scale. So after running this, all the features will have mean 0 and standard deviation 1. Then we just skip the part of perception because we have done this in other video. But right now we will run this decision region function because we will use it later. And this function is to plot the millions of dense points on the map. And this map will represent the predicted label from the trained model. And we will also plot the real observed points on this map. to show if those two match. We will use this function later. Then we will skip this training for the perception, but we will use this data for the combined because it will be used later. So also skip the logistic regression part because this is done in other video. Here also logistic regression with scikit-learn, but we do not use this. Support vector machine, also done in other video, so we just skip this part. Decision tree learning has been done in other videos, so we just skip. So we come to k-nearest neighbors, a lazy learning algorithm, this part. So we just create an instance of the class k-nearest neighbor classifier class with neighbor 5 and p is 2. Minkowski distance. This is the distance combining is a balance between the Euclidean and the distance with the absolute value. So this is called Minkowski. Can fit this training data. So it is done, and we will plot the decision region for the combined for this test for the decision region for all the data observation, and we also will plot all the dense points with different colors for the region, and we show and this index for the test index. We show this map. Take a while. Can see these three different color region is the modeled region. So based on the model change, we have millions of points in this rectangular map. Then each point map very dense represents a label projected from the model. Then we set the colors for different label. So this is the model's region, and these points are the real observed points from this combined data called STD. This data. So you can see if you download this figure, you can zoom it and enlarge to look at there any wrong projection from the between the observed points and the model's points, right? So this is the basics of the k-nearest neighbors. Thanks for watching.